In this lecture, we will discuss two important coordinate systems that provide us a framework to solve the problems of fluid mechanics. And these are the Eulerian coordinate system and the Lagrangian coordinate system. As we mentioned in the first lecture, the main goal of this chapter is to derive the equations for the basic laws of conservation. And in the previous lecture, we learned that to derive these equations, we have to choose the continuum method. So after choosing the continuum method as an approach to derive these equations, the next task is to choose the coordinate system in which we want to formulate these laws. Basically, there are two coordinate systems that are given by the Eulerian coordinates and the Lagrangian coordinates. So let me first discuss the Eulerian coordinate system. In the Eulerian coordinate system, the independent variables are the space coordinates xyz and time t. The space coordinates could be the rectangular coordinates, or they could also be the general curvilinear coordinates. In the Eulerian flow description, the motion of a fluid is given by prescribing the necessary fluid properties as functions of space variables and time t. For example, the velocity v is given by the velocity field v that depends upon the variables x, y, z and time t. Similarly, the temperature is given by the temperature field T that depends on x, y, z and t. Similarly, the density function is given by this one. Etc. In the Eulerian coordinate system, we focus on the positions of the fluid particles in a fixed region of space, and that fixed region is called the control volume. This is a control volume, and the dots are the positions of fluid particles in this control volume. A control volume and its types would be discussed after next lecture. As the fluid flows through this control volume, then the fluid particles in this control volume at some time t equal to t naught would be different than the fluid particles at some subsequent time t equal to t1. In the Eulerian coordinate system, we obtain the information about the flow in terms of what happens at fixed points as the fluid passes through these points. For your comprehension, let me give you an example. Consider the smoke discharging from a chimney. In the Eulerian description, we may attach a temperature measuring device at the point A. Suppose that the coordinates of point A are x0, y0 and z0. The temperature measuring device at this point will record the temperature at this point as the function of time t. So the temperature t at the point A is the function t, which depends upon x0, y0, z0 and t. Similarly, by using the temperature measuring devices at various locations within this region, we obtain the temperature of this region as the function of variables x, y, z and t, where x, y, z are the order triples of the points within this region. So this field variable denotes the temperature of this fixed control volume. Okay, so we say that in the Eulerian coordinate system, any parameter of the motion of fluid is given as the field variable, which is a function of the space variables and the time t. Okay, let me now understand the Lagrangian coordinate system. In the Lagrangian coordinate system, we focus on the fluid particles as they flow. In this description, the motion of fluid is described by giving the trajectories of all fluid particles. It means that we tag the fluid particles and determine how the fluid properties change with the time t. In this coordinate system, the space variables x, y, z and the time t are no longer independent variables. Suppose that at initial time t0, we tagged a fluid particle that was at the position x0, y0, z0. We can tag it by coloring it without changing its density or by attaching a temperature device with it, etc. Note that as the fluid element flows due to motion of the fluid, then the fluid properties that are associated to this fluid element will change as the function of time t. Okay, so any fluid property f is given as the function of time t. The question is, how can we individualize this fluid element? The fingerprint to individualize this fluid element is its initial position, this one. We say that this is the fluid particle that passed through this initial position at the initial time t0. Okay, so any fluid property f will also depend on this initial position. So in the Lagrangian description, the independent variables are x0, y0, z0 and the time t. Okay, but since x0, y0, z0, this is a fixed point, therefore we say that this fluid property will depend on time t only. Alternatively, this fluid property in the Eulerian coordinate system is given as the field variable f, which depends on the space coordinates x, y, z and the time t. But in the Lagrangian description, we follow this fluid element so that it changes its positions as the time t changes. It means that the coordinates x, y, z are no longer independent coordinates. Instead, they depend on the time t. Therefore, this equation becomes f equal to f of x of t, y of t and z of t and time t, which is a function of time t only. So in the Lagrangian description, the fluid properties are given as the function of time t. Okay, I hope that you have now understood the difference between the Eulerian coordinate system and the Lagrangian coordinate system. As a final comment, I will say that in order to derive the equations of laws of conservation in the Eulerian description, we have to apply the laws of conservation on the fixed control volumes, and in the case of Lagrangian coordinate system, we have to apply the principles of conservations to the moving fluid elements. I hope that you have learned and enjoyed today's lecture. Thanks for watching.